Hello, hello.
Ukimkosea heshima, tutakulazimisha umheshimu, my friend. Nataka nikwambie
उत्पन्न.
Okay, hi everyone. How are you doing, guys?
Fine, good.
Yeah, okay, great, guys. So, hi, welcome everyone. So today we have new peoples to join our batch. So today it is a open for all the public class where we gonna understand the OSPF protocol. Okay, so hi guys. My name is Shank and I will be your instructor for this course. And about me, I am triple CCI certified, having 13 to 14 years of experience, and I worked in almost all organizations, whether it is enterprise or service provider. And I work on all the technologies related to routing, switching, data center, enterprise technologies, and service provider technologies. Okay, so as a part of the course who joined today, guys, so this will be your OSPF, BGP, and MPLS course, which is a combo batch. Okay, so let me answer some of the basic Q&A that you have, you guys, and then we're gonna start with the topic of today. This is a live class, guys. So again, what I am teaching in the class, that is gonna be live here only. Okay, so it is not a demo or something like that. I'm gonna start with the OSPF and then we're gonna go at. Okay, so just give me a second, guys. Okay, guys. So to answer your basic questions, like what we're gonna cover it up, what is the course content, what is the timing of the course. Okay, so this is a weekdays batch where I'm gonna take the class from Monday to Thursday. Okay, and it is gonna be from 10 p.m. to 11 p.m. IST, one day class, one hour class every day. Okay, guys, and the course content that we're gonna cover is, let me open the links for you, just a second. Okay, so this is our page on the Network Journey website. You can also go to that page to see the course content. Okay, so we're gonna cover it OSPF in complete detail. Okay, which is covering our theory part as well as our lab part. Okay, we're gonna cover our BGP from the starting to the basics to the up to the advanced level. Okay, which is again gonna cover the theory and lab, and then I'm gonna cover the MPLS, which is again from the basic till the level that we are having in the enterprise environment. Okay, so there will be more MPLS which is in the service provider, but for the enterprise, whatever we need, we're gonna cover it up, the whole thing. Okay, all the sessions are covered. First of all, I'm gonna take the theory and then I'm gonna do the lab. Okay, so when first we're gonna do the OSPF theory, and then we're gonna do the lab, then BGP theory, then lab, and then MPLS theory and lab. So let me show you guys the workbook. Let me first show you the topology on which we're gonna work. Okay, so this is gonna be our topology where we're gonna configure the OSPF BGP in different parts of section. Okay, and then the workbook. Okay, so you will have a complete workbook which you will get from the OSPF to BGP and MPLS. Okay, so this is gonna start from here, which is with the OSPF task. So it's gonna start from the configuring from the scratch, where you need to configure the IP address and then how to configure the OSPF process, what are the different debugs, okay, troubleshooting of OSPF, how you're gonna change the timers, everything, okay, authentication and all. with all the diagrams, all the steps, all the explanations. Okay. Then advanced OSPF topics. Okay, like your passive interface, stub, NSSA, summarization, route filtering, virtual link, and all. Okay, so it's gonna cover everything. Okay, so this is the workbook that you get of every topic, which is OSPF, BGP, and then MPLS. MPLS also I have a different workbook which is configured for the MPLS topics. Okay, step by step workbook. Okay, guys. So before I gonna start with the today's topic and today's class, I want you. I have 2-3 minutes. You can have any question or anything you can ask me. Okay, and also we're gonna provide you the lab access, which is gonna be 24/7 lab access till our course end. And if you stuck at some point, we will have a dedicated lab instructor present, which gonna help you out. Okay, and all the sessions that I took is gonna be recorded and it's gonna be shared in next few hours. Okay, so it's gonna be automatically uploaded to a private portal which you will have it, and you can watch it anytime whenever you have time. Okay, so before I gonna start with the topic, you will have 2-3 minutes, 3 minutes, so you can ask me any question that you guys having related to the course, and then we're gonna start with the topic.
Hey, my name is Mohammed Iftikhar, and I just want to ask you about that. Is this course? I want to ask you about the level of the course. Like, it's for the beginners, it's for the intermediate, or it's for the advanced level. Do we
So
need
it is gonna
CCNA
be,
before this?
so again, it is gonna be from the beginning to the intermediate level, okay, and some portion of advanced level as well. For if I talk about the knowledge point of view, so again, what I expect you guys, you should know what is IP address, what is TCP, okay, right? So basic things, how you configure the IP address on the interface, what is link state protocols, what is distance vector protocol. That's it. Nothing much about any other thing. Okay. Okay. Anyone
Yeah,
having any other question?
yeah,
Yeah.
this sound good. So, what's the duration of this course? Like, how much time it will take to complete this course?
So every module is gonna take a week, okay, to complete. So it's gonna be around 3 weeks to 1 month for OSPF, BGP, and MPLS to complete all the 3 modules. The class will be held from Monday to Thursday from 10 p.m. to 11 p.m. IST.
How much cost, sir? Free.
For
course.
cost, you will get a link in the chat. You can do a email or you will get a WhatsApp number. You can directly talk with the backend team. They're gonna help you out with that. Okay, guys. Any other question? Yes, Mohammed. You can go ahead with your question. Okay. Someone else having any other question before I start with the topic of the day?
No.
Okay, so this is the link which is pasted in the chat. Okay, you can click on it. You will get the course contents, and also you will get a link soon for pricing and all. Okay, guys. So if you're not having the question, let's start with this today with the OSPF process or your OSPF protocol that we are having. Okay, guys. So for new people or even the old people also, you can answer me. Okay, I'm gonna ask some questions with the very basic questions. Let me share my screen. Okay, guys. So I hope everyone is able to see my screen, right? So right now it is blank. Let me write OSPF. Okay, guys. So tell me, which type of protocol is OSPF? It is distance vector or it is link state? Anyone of you can answer.
link state protocols.
So OSPF is a link state protocol.
Yes.
What do you understand by link state protocol?
Mm.
So anyone can answer what do you understand by a link state protocol?
No.
Okay. So link state protocols are the protocols who will have complete picture of your network topology. So what do you understand by complete picture? That means they will have the complete, or I can say all the paths, to reach destination. So in real life, if I give you an example, these are the protocols which are like your navigations. Okay, like Google navigation, you have Apple navigation, Apple Maps, Google Maps. So if you want to go to a particular destination, you put your source, you put your destination, and it's gonna show you all the paths through which it can reach to your destination in the shortest time, right? So this is how the OSPF protocol or the link state protocol works, which will have all the paths, all the complete picture of your network topology, and then you can reach to your destination through that. Okay. OSPF is an open standard protocol. What do you understand by open standard, guys?
Non-proprietary.
Okay, so it is going to be supported by all the AMs. All the OEMs, it is open standard, right? Non-proprietary. You can say it like that. Okay. Sorry, Mari?
It's a vendor neutral. It works on
Yeah,
any vendor
it is.
equipment.
Yes,
Yeah.
it is vendor neutral. So all these answers are correct. Okay. Okay. So tell me, guys, the advantages of using OSPF. So one is open standard. What else?
Fast convergence.
So it is having a fast convergence because it knows all the routes pre-hand, right?
We can have different vendors device in our network topology.
Yeah, so that is mean by open standard. Okay.
okay.
It is having a hierarchical design, which is known as two-layer access design. Right.
We have a concept of areas.
Yes. So through areas. Right. It can support your large networks. Okay. So these are some of the advantages. Can anyone tell me what are the disadvantages of using OSPF?
Yes, equal cost load balancing. It is
What
not
is
enough.
Sorry?
Equal cost load balancing, the feature of the EIGRP that is not in OSPF.
So OSPF also can do equal cost load balancing.
Having the different type of bandwidth, 2 Mbps.
So that is known as unequal cost load
Oh,
balancing.
sorry, unequal cost load balancing.
Okay, so it cannot do unequal cost load balancing. Okay, so that is one disadvantage. It consumes more. So
CPU.
guys, after you speak, if you don't want to speak further, you can please put your mic on mute. Thank you. So it's gonna consume more CPU resources.
It works on the layer 3.
Okay, so works on layer 3. What does it mean by works on layer 3, and what is the disadvantage in that?
Let's say it's a protocol 89. So if it is a layer 2 issue or link level advantages wise, it is not good. So we have less control over there because of L3.
But every protocol works on L3, like EIGRP or BGP or ISIS.
ISIS, it's link layer, right?
So that is using a different set of protocol, which is like CLNS.
Yeah.
But again, all these protocols are worked on L3 level, but that's what they use the IPs.
Okay.
Okay. Okay. What else? So you can only do summarization on ABR and ASBR. So again, those who not know what is ABR, ASBR, I'm gonna tell you in next 5 minutes. So you cannot do summarization at any point. These are the only specific point where you can do the summarization.
I guess works on layer 3 will not be the disadvantage then.
Yes.
It has to know all the LSDBs everywhere.
So sorry.
It has to know all the link state databases.
So that's why it needs more CPU resources.
Yeah.
Okay. So these are some of the disadvantages. So every routing protocol, when you run, it's gonna use a algorithm in the behind the scenes. So what algorithm OSPF uses?
Shortest path first.
Okay, so shortest path first.
It's a Dijkstra algorithm.
Path first, which is a mechanism, okay, which is given by Dijkstra, right? Okay. So whatever is from source to the destination, what is having the shortest cost, it's gonna use it. So for example, the cost between these two links, every link is the cost is 10. So on the top path, I am having a cost of total 20. Okay, so this is my source, this is my destination. And from the bottom link, I am having a cost of total 30. So what OSPF is gonna do? It's gonna uses the first link. And guys, if you are having the same cost on both the links, then what OSPF is gonna do? If your topology is like this, okay, so cost here is 10, here is 10, here is 10, here is 10. So on the top link, you will have a cost of 20. On the bottom link also, you will have a cost of 20. So tell me, what OSPF is going to do?
Both the routes. Gonna install both the routes in routing.
So what does it, what does this method known as? It is known as equal
round
cost
robin.
load balancing.
Round
Equal
robin.
cost load balancing. Okay, so equal cost load balancing, it can use both links, and by default, you can go up to, by default, it is having the, it can go load balancing up to 4 links. Okay, there is a range which you can use it. So up to 16 links you can go if you want.
So
Okay.
Can you explain the equal cost load balancing? How it does?
Okay. So equal cost load balancing means it's gonna use your both the links to send the traffic. So this is your first link. Okay, because again, the cost is same. This is gonna be cost of total cost from source to destination is 20. And on the bottom link also, the cost is gonna be same, okay, which is 20. So it's gonna use both the links to send the traffic, first link as well as second link. That is known as equal cost load balancing, okay, or load sharing also, you can say.
So that means it's going to, distribute that data traffic between the two links. Is that it?
Yes, but again, guys, it depends on your method of switching which you are using, which is there are two methods. One is process switching, okay, and another method is self switching. So by default, all the Cisco routers and switches now using this method, okay. If you are using this method, then the load balancing that it's gonna do is per destination, okay, that is by default. If you want to change, you can change it to per packet as well. So let me tell you what is the difference between per packet and per destination. So for example, I have a source and I have a destination is 3333. Okay, and I have one more destination which is 2222, and my source is here on the left side, which is 1111. So whenever 1111 needs to send a packet to 2222, okay, it gonna use the red link always, okay, for all the packets that it gonna send. Okay, so that is known as per destination, which is the by default load balancing method. Okay, if then when the 1111 wants to send the packet to 3333, then it's gonna use the green link to send it to the other destination. Okay, so this is gonna happen in the first one, which is known as your per destination. When if you enable, so by default the per destination is enabled, so your traffic will go like that way. But if you enable the per packet load balancing scheme, which is via one command, you need to do it. Then what it's gonna do, if 1111 wants to send a packet to 2222, if all the packets to 2222, then what it's gonna do, it's gonna use first link to send first packet, second packet it's gonna send to via second link. Okay, so this is the method through which it's gonna, so per packet it's gonna change the links. Okay, so this is what you can do as well. I hope that is clear now.
Yes, thank you.
Okay, guys. So after that, let's talk about the concept over which the OSPF works, which is known as OSPF areas. So OSPF is having different areas to use as a in the protocol. Okay, so some are basic areas, some are advanced areas. So we're gonna talk about basic areas today. Okay, so in basic areas, you will have two area types. One is known as backbone area. Another one is known as regular area. Okay, so the first area that we're going to talk about is backbone area. So backbone area is known as area 0. Okay, it is always area 0. So this is the number of the area which is always going to denote by a backbone area. Normally in our productions, we will make our core layer in the backbone area. Okay, so go to distribution, we make it. Okay, normally we don't have end users in this area. Okay. It is known as transit area as well. What do you understand by transit area? The area through which the traffic of other areas goes. Okay. The second area that we are having is known as regular area. So this is basically non-backbone area. And it is the area which is user created. Okay, so user gonna creates that area. All of your regular area is compulsory, okay, connect to your backbone area. Okay, so if I want to summarize what I have written, you will have two areas, backbone areas, regular areas. If I draw a diagram for you guys. So let's think of this area as area 0, which is my backbone area. And the other area is, for example, I took one area which is known as area 1, which is my regular area. So if you can see, R2 is the router which is connecting my area 0 to my area 1. So every area needs to connect to your area 0. So what does it mean? If I am having one more router R4, so I cannot make area like this, okay, which is area 2, which is again a regular area. Okay, so this you cannot do. Basically, you can do via there is a concept of virtual link. Okay, but as of now, do not think about that one. That is a temporary solution. Okay, so you cannot do it like that. If you want to connect a area, you need to connect it with your area 0. Okay, so that means like this you can form if you want. Okay, so like this is my regular area, which is area 2. So anyone having any question and doubt in this?
No.
Okay. So can anyone try to guess why this is a requirement? That all of my regular areas should compulsory connect to my backbone area. And this is the most important question which is gonna ask in the interviews as well.
Because backbone area is a transit area, through that we have to communicate to the other areas.
So that's
So
okay. But why?
To exchange
DR will be sitting in.
Sorry?
Maybe we are keeping all the important resources like servers and everything in area 0. So
we are not
needs
putting any of your end devices in area 0. I already written it. We don't have end users. We don't have no servers, nothing.
Okay.
For route distribution, like to share every routing updates.
So what is the issue if I connect one area here? It can also share it. Any other guesses, guys?
Loop, maybe for loop prevention.
Sorry?
For loop prevention, maybe.
Okay. So loop prevention. How it gonna do the loop prevention?
Because just every router to prevent the loop, every router should have full knowledge about others, and this can be done through the backbone area or area 0. So, and maybe we can create virtual areas so that it can be
That to avoid LSF load.
sorry.
Okay.
We can say
So,
because of ABR concept,
sorry.
area border route. Maybe because of area border router concept. Because
avoidance.
So
Loop
as
avoidance.
El Shade told us, okay, at the first, we use it for loop prevention. Okay.
See.
So how it gonna prevent the loop? I'm gonna tell you. So for example, this is my R3, which is now gonna connect to R4, which is now gonna connect to R5, which is now gonna connect to my R. So I have R4 2 times. So let's write it R6 here. So now let's assume like I am having area number 3, which is this one. So what is going to happen? R4 is having a update which is 4444. So this is a network which is present here on the R4. Okay, so it's gonna goes like this to R1. Then through that it goes via area 0, then R2, then it goes like this. Okay, like this, 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 and then R5 is connected to R4. So what R5 is gonna send it? It's gonna send the same network which R4 is generated to the R4. Okay, so this is how your loop can be occurred if you are sending your routes which are connected to your regular area. So area 3 is my regular area and area 2 is also my regular area. Okay, so to avoid this, they have made the backbone area so that every route will go via area 0 and there is no exchange between your regular area. So this route or this update which is coming, okay, it is gonna stop it here directly. So it's not gonna go to the R4. Okay, and same is the case vice versa. If R4 wants to send this update to here, that also not gonna go. So nothing is gonna exchange between your regular areas. Everything will go via area 0. So to avoid the loops, only that is the concept. Okay, guys. And one more question I have: why they making these areas? What is the use of having different areas?
Minimize the load. Router minimize the load overhead.
How
Yeah,
it gonna minimize the load?
In the same
adjacent.
route, we have partitioned a big area into a smaller area, so that the fast convergence, I mean the routing updates will be low in comparison or suppose there is one area, all the routers are there. Definitely the utilization be high, convergence will be slow.
Okay, anyone
Hey,
else?
hey, Shank, I think basically it's used, to minimize, the size of the routing table on each routers. Yeah. So instead of having, the exact same routing table on all the routers, we're using that concept, so that we can reduce, the size, of the routing table for each routers. Yeah. And also that we some way, reduce, the CPU processing on those routers.
So Mori,
from my point of view,
just a second, Perry.
like
So
if
Mori,
we lose any route from another area, so it's gonna send like the update message to every router. So and like sending the updates to every router is gonna be like more usage of like it's gonna be a disturbance in the like the algorithm that the OSPF is using. So it's gonna be like more usage of like resources and everything. So if we divide the areas, and then it's gonna be like send the package to only the backbone area, and it's gonna send further.
Okay, so I want to discuss Mori related to what you said. So you are saying like it's gonna reduce the routing table, right?
Yeah, the size of the routing table. Yeah.
So her size of the routing table. What do you understand by the size of the routing table? Like if I am having 4 routes, okay, then instead of 4, I will get 2. That is what you are saying?
Kind of course, for example, if you consider, the distance vector routing table, so they will, broadcast, the full routing table, to the other devices. So this is not the case, for the link state. They
And
only
also,
consider,
and
part of the
also,
routing.
and also,
Just wait,
yeah.
wait.
Oh,
If someone is saying, guys, please wait for your turn. Yes, Murali.
Yeah, like I was saying, distance vectors routing protocol, they will advertise, the full routing table, to all, the routers, the topology. But for link states, routing protocols, they only advertise, part, of the routing table, what is needed, for the other routers, in order to have a view, maybe reach out to reach out
So
to the part of the
Mori,
network.
you are confusing between two things. I will explain you where you are confused. Okay, I will tell you. Okay, so yes, Ashlade, what you are saying? El Shade. I hope I'm
okay.
spelling it correct.
Yeah. Just what I was trying to say is that, for example, if we have 6 to 7 inches on R2, which comes through R2, I mean in area 1, and another 7 inches in area 2. So when we use area border routers, this can be summarized to a single subnet, and it will be advertised to area 0. So in that case, we are just reducing the routing table into two paths. I mean two lines instead of more subnets that will come to the routing table.
Okay, so guys, to make you understand the thing in a correct way, I will tell you. See, your subnets is gonna be advertised. All the subnets is gonna be advertised. So it's not gonna reduce your routing table in subnets. For example, if I am having a R1 which is 1111, R2 is having 2222. Okay, I'm running everything in OSPF. Okay, and let it them into the whatever area you want to consider. You can consider in whichever area it is there. Okay, so 4444. So I am running these networks, which are 6 networks. Now, if I see on any of the router, okay, so if I want to see it on R6, so on R6, how many subnets I gonna see? If I'm advertising every subnet in OSPF.
I should see them all. Yeah, 1, 2.
So you're gonna see all, okay?
Yes.
So your routing table will not gonna reduce in that way, okay? But how it gonna reduce? Let me tell you now. For example, I have 2 more routers which are connected in this area. Okay, so now what is gonna happen is, if R2 is sending a particular route, if this subnet is I am advertising in this area, which is area 0. Okay, so now to reach 2222, R1 is having 3 equal cost path. Okay, so one, it can go through this, it can go through this, it can go through this. Okay, so when you see the routing table of R1, you will see that 2222 can be reachable via 3 paths. Okay, guys. So that way your routing table is going to be big. Okay, but when R2 is going to send the update to R3, what it going to send? That if you want to reach 2222, just send it over one path. Okay, so your internal area structure is going to be hidden from the other area. Okay, so your detailed LSA or your detailed flooding is going to be hidden from the other area. So that way it's gonna reduce the routing table. Okay, but do not think like it's not gonna even send the 2222 subnet. Your all subnet is gonna be present, but all paths will not all routers able to see. Okay, so there are tables in OSPF which is gonna show you the different things. So first table is gonna be neighbor table. okay, which is known for all the neighbors. So when you create the OSPF neighbors, it's gonna show you all OSPF neighbors. Okay, second one is gonna be topology table. So topology table is gonna show you all routes, okay, or subnets information, okay, or I can say topology, how to reach them, what to do it. And you will have a routing table, okay, which is gonna show you in case, so there is a concept of inter area and intra area. So when you are sending a traffic in the same area, okay, so for example, this is, I already done it, but let me make it. So again, 2222 is a part of area 0. Okay. So if I'm sending a traffic to a same area, that traffic is known as intra area traffic. And if I'm sending a traffic to a different area, so from R1, if I'm sending to R3 or R6, R5, wherever I am sending it, okay, that traffic, so for example, here to here, that traffic is known as inter area traffic. Okay. So now guys, your intra, so routing table will gonna show you the best routes. Okay. But now the concept is between intra area and inter area. So in intra area, OSPF will work like link state. It will have the complete picture. What do you understand by that? The between R1 and R2, I know all the three paths through which I need to send the traffic. Okay. But between inter area, your OSPF will work as a distance vector protocol. Now, what is distance vector? So for example, R3, if wants to send a traffic to 2222, which is in area 0, or for example, R3 wants to send a traffic to 1111, which is also in area 0. Okay. So if you guys confused in that topology, let me make it again here so that I can explain you this concept, which is important concept. So this is 2222. Okay, this is 1111. And everything, this thing is in area 0. And R3 is here, which is having 3333. Okay, and this link is in area 1. And in my in the area, I have more links like this. Okay, so when I want to send the traffic between areas, which is inter area, okay, in that case, R3 is gonna send the traffic to the connected router. Okay, it don't know about the internal paths, which path your traffic will go to reach 1111. Okay, so I3 don't care about it. What it cares about is it, I need to send it to my neighbor. That's it. So that these way of working the traffic is known as distance vector. But if you want to send the traffic from 1111 to 2222, then you will have a complete picture of the topology through which you want to send. So you can go via this link, which is the first link. You can go via second link. You can go via third link, right? So this type of thing is known as in inter area or link state. Okay. So I hope you guys now clear about these things. Anyone having any doubt, any question?
No.
Okay. So after this,
database table.
what is database? So again, your topology table is also known as database table. Same name. So same concept, only the names are different.
Okay.
Okay. So the next topic and the last topic for today is gonna be OSPF router type. Okay. So in OSPF we will have different routers which we call by different names. So R5 is connected to a router where we are running EIGRP. Okay, we are not running OSPF here. We are running OSPF area 1 in this field, OSPF area 0 here. Okay, and on R5 we are redistributing between OSPF and EIGRP. So those who don't know what do you mean by redistribution. So if you want to send a traffic from one routing protocol to another routing protocol, there is a method to send the traffic. That method is known as redistribution. Okay. So now guys, let's understand different names for different routers that we are having. The first one is known as internal router. So internal routers are the routers with all interfaces in same area. Okay, so tell me guys, from the above picture, what are the internal routers in this topology? So I can say R1,
R2,
R2,
R4,
R4. That's it. Okay. So these routers are known as internal routers. The next category is known as backbone routers. So backbone routers are the routers in and connected to area 0.
R1, R2, R3.
So that is going to be R1, R2, and R3. Okay, all good till here. So now understand the next two different categories which are most important. Okay, so the other category is known as area border router, which is also known as ABR. So these are the routers in between areas. Okay, or I can say interfaces attached to multiple or multi areas. So what are our ABR?
R3.
So R3 is the only router which is ABR here. Okay, so this is known as ABR, which is area border router. And the fourth router is known as autonomous system boundary router, which is also known as ASPR. So this is a router which is going to do the redistribution for you, which means from one routing protocol to another routing protocol to basically OSPF. Okay, so in our case, R5 is known as ASPR. Okay, so anyone having any doubt in this? Okay. So guys, that's all I need to teach today itself. Then from tomorrow onwards, this class is going to be logged. So it is not for every public. It is only going to be for the persons
Hello.
who gonna enrolled. Okay.
Hello. So
Yes.
the question here is why is the internal router R1, R2, and R4? Because I can see on area 0 there's R1 and R2, and then R4 being the internal router. So I don't really understand the concept of the internal router.
So internal router is the router which router is having all the interfaces in the same area, no matter whatever the area. Okay.
But from what I observe, R1 and R2 is in one area 0. Then R4 is in area 1. I don't think are they in same area.
So so they are not in the same. So R4 having all the interfaces in same area or not?
Exactly.
Okay, so there all the interfaces in area 1, right?
Yeah, because area 4, area 1, I can see R4 in area 4. So I can see I can see router 4 in area 1, and then I can see
again. I have not written like routers with all interfaces in area 0. I have written the router with all the interfaces in same area, no matter whatever is the area. You getting my point?
not too clear from.
Okay, so see it. Let me tell you. So R1 is having all one interface only. Okay, which is going towards R2, which is in OSPF area 0, right? R2 is having two interfaces, which is in area 0, right? Then R4 is having two interfaces, which is in the area 1. So what is your issue? So all the routers are having the same area.
Okay.
It doesn't need to be area 0.
Okay.
You're getting my point?
I get your point. So it doesn't have to be in area 0.
Yes, it doesn't have to be in area 0. Okay. Okay, guys. So that's all for today. Tomorrow that this meeting is going to be logged. So those who want to enroll, you can enroll it today itself. You will have the link in the chat for this. Okay. So Chandan, I already told you class timing is again the same. From Monday to Thursday, it's going to be 10 p.m. to 11 p.m. IST. And it's going to go for around 1 month. Okay. I took like OSPF for 1 week, then BGP for 1 week, then MPLS for 1 week, and 1 week I take it as a buffer. Okay. And guys, you can ask, you can take, you can go to the support link and then on our page as well. Okay. You can get the fee structure and all. So WhatsApp for your inquiries, you can click on WhatsApp. Okay. Everything is there. Okay. So that's all for today. Tomorrow it is going to be a loud class, guys. So this is the only class which is freely available for all. Okay. Thank you, everyone. Have a great day. Bye. Thank you.
Bye.